There's a calendar. See my math shirt too? I wore this as if I was a student. This is what a student wear. Dear math, grow up and solve your own problems, right? Does you feel that way sometimes? It's supposed to be math shirt Wednesday, but then the tie dye / neon kicked in. Go this way. So we can see that. Double T sometimes to turn my back. Oh no! Oh, it's gonna be the bad sound. It's really gonna be bad. That noise. This one, when I turn my back, you can't even hear me. This is the worst microphone ever. Okay. Ooh, remember I did that. Math. Probability. 5. I will in a minute. I'm gonna do 18. Actually, I probably should have done. There's one of them that the phase shift is not good compared to the period. So we figured it out in tutoring what we could do with our specific coordinate plane now that we have it. Let me just get the 8 of the seating chart just to see who's student number 7. Mike Kennedy, actually 7. All right. So you get pick first. I think I need this here. All right. So let's have a little discussion. So let's skip to 0 right in the middle here. What'd you get for tan of 0? You are correct. Kennedy, was that you? Okay. Thought I heard some other things. All right, what about pi over 4? Which, you probably already know the answer, but that's why I put this over here. So it's the 45 in quadrant 1. So what's the tan of that? Oh, no, that's sine and cosine. Tan is y over x. So it's, and what do you get for that? What's that again? Sorry? 1. All right, and then what's tan of pi over 2? And pi over 2 is up here with that coordinate. So tan of pi over 2 is up here, and that's, what's tan, by the way? What letter over what letter? So what's y over x? Undefined. What happened yesterday with undefined values? Starts with an A? Asymptotes. Let's keep going. 3 pi over 4, that's in quadrant 2, this 45 that I kind of highlighted over there. So look at those sides. What's the tan of 3 pi over 4? All right, and then I'll get somebody else just to shift it around. 2, nice, good. Angel, I'm always in the way here. Move. There we go. All right. Yeah, I almost closed that. Angel, what's tangent of pi, which is over here? 0 over 1 negative. Sorry, 0. You didn't say that. I said that. And then 5 pi over 4, which is in quadrant 3. What's the tangent of that? Say that one more time. So it's this one here, tan of this. Remember how to do this? 1 negative over negative. And then what's 3 pi over 2? Tangent. Undefined, which we have another asymptote. And then I'm going to go backwards. I'm going to go backwards here. Negative pi over 4. Let's get somebody else. Let's just keep the tension high in here. Kaylee, the negative pi over 4 is actually this triangle. Let me get highlighter instead. So it's this triangle. It's directly 45 degrees clockwise. And then I don't know if you can see those, but you should know it's 1, 1, root 2, but it's down 1. So what's tangent of that angle measure? Negative 1. So now I'm in the way again. Gosh, so annoying, Mr. Samuelis. And then what's tangent of negative pi over 2, which is exactly there again, which we already answered that question. It's this one right here. This is negative pi over 2. Undefined again. The reason we had to go to negative pi over 2 and my coordinate plane doesn't really match this, because here's negative pi over 2. And I'm not going to go any further than that. But I did want to go backwards here because of what happens with tangent. There's that asymptote. And then negative pi over 4, I'll put that up here. This is negative 1. Input, say it. Output. And then 0, 0. And then pi over 4 I will put here because pi over 4 gave me a value of 1 as output. And then pi over 2, I guess I'll put that. I don't know why I put a negative there. Pi over 2 is right here. All right. And then I did this in the other class. I did this and understand something. And that is pi over 2. Well, here, let's type it on the calculator. Pi divided by 2, seconds pi. We don't do this anymore because, we take a lot of rigor out of what we used to make students do. We used to make them discover a lot of stuff. So actually the chart was much more obnoxious. We would actually have those values, but then I would put on the chart, hey, take the tan of 1.57. Stop. Because 1.57 is this x value right here. Actually, I'm probably not giving it a good enough, it's actually even closer than that. Because once I round, it actually isn't pi over 2 anymore. You guys get that, right? You understand how this is 1.57 for x. This is why asymptotes are what they are. I'm going to use the mouse instead. Now when I take the tan, not of that, the tan of 1.57 and then stop, I press enter, I get a huge number. Input, say it. Output. That is what this means. This is why this is why the asymptotes are doing this. Because the closer that I get for x, the y's start taking off when I input those x's. And then the same thing, I did this with the other hour, and we used to do this. We used to make you write this down, so you proved the asymptotic behavior. Just short of negative pi over 2, you get a huge negative. Is that right for me to say that? Remember the rant yesterday? No, it's not. A very small negative is what I should say for that, right? Right. All right, so that just piggybacks off what you saw or heard in the video. All right. And then, okay, well, here we go. You know what? I'm going to go. Oh, I'm sorry. I didn't finish. So then where I lost my chart there. So that's pi over 2. And then the reason to keep going is just to prove the repetitiveness, prove the periodicity of this. Ooh, did I just make up a word? All right. To prove that this is just a repeat. We got an asymptote here. And then this is, sorry, you're in the way there, 0 and then 1. And then, okay, I got the exact same graph. So what is the period of tangent? Let's talk to somebody on this. Student number negative 1,200. No, that don't work. This is the fastest way, believe me. Enter. Nice. Reese. What's the period of this graph then? What is the distance that the graph is unique, and then after this distance it repeats? X-axis distance. So what's this x-axis distance? So this is pi over 2. This is pi over 2. What's pi over 2 plus pi over 2? If you say pi over 4, you're suspended. Pi. Thank you. Did you hear the pressure in this class? He's going to suspend a student for getting the wrong math answer? Maybe. Fraction seniors. All right. What's the amplitude, everybody? 3, 2, 1, go. Who said 1? You're suspended. Because what's the amplitude of this? None. Suspended students? None. Let's face it, a suspension is just a free day off. Ooh, I'm sorry. All right. Anyway. Okay, so here we go. 8 for 8. Matt. Oh, fumble. Okay, almost. Matt, cotangent's easy. I hate when he says that when it's my turn. Like, let's look at the chart. What's cotan compared to tan? It's the, or not really opposite. Opposite means negative. All right, so what's the flip of negative 1, Matt? Ooh, you just did opposite. What's the flip of negative 1? Still -1. All right, now you want to get nuts. Here we go. What's the flip of 0? There we go. And then what's the flip of undefined? It is, because that's 0/1. Wrong. That's 1/0. Now it's 0/1. I did that wrong. Nobody else. All right, what's the flip of 1? I mean, this is all we have to do. Once we get the tan graph, we can do the cotan graph. Super simple. And I'm not going to keep asking the same questions. You get it. You get it. Undies, and then 1, and then 0 for that. And then when I graph these, it's kind of annoying to graph it over here, but I'll do it. 0, and then this is at same values, -pi/2. If you wanted to complete this, -pi/4. That's going to be in the way. -1. This is just a little part of the cotangent graph, sorry. And the asymptote starts right on the y-axis. That's nice. You're going to like cotan probably a little better than tan because it's a little easier. Pi/4 I do want to put here. Pi/2 input, output is all this is, this little game that we keep playing. 3 pi/4. This is why I squeeze this together too. And then you have 1 here and -1. So I squeeze this extrapolation together on one page so that I can continue on the other with maybe some handout notes, and I felt pretty good about that. And then out to 2 pi, which I did not go. I went up to 3 pi/2, but you can imagine a 5 pi/4, 6 pi/4, 7 pi/4, and then 8 pi/4. Even though we don't have that in the chart, that is the next asymptote. 2 pi, the tan of 2 pi is the same thing as the tan of 0. So that's why you know that. So you see the repetitiveness again. So you see the periodicity of this. I don't know if I'm making up a word there. I like it. Holy cow, did I miss that point by a long shot. All right, and then I won't do that proof because actually it's hard to type cotan on the calculator. What's the amplitude, everybody? Don't fall for it. 3, 2, 1, go. None, but there is an A value that stretches and shrinks. So don't get tricked on that. And the period again for this is pi. Okay, so now on the very next page, here's your parents that you should understand. Tangents, and you have space up at the top to write this down, so you should. See that little space up there in the next page? So you kind of squeeze that in there, what you're supposed to know about tangents. So what happens with tangent? The period gets cut in half. So if you look at what I have written here, maybe highlighting will do it so you know what I'm talking about. That says pi/b. And by the way, I don't want to shortchange this. The big deal, the big difference with tangent, cotangent compared to sine, cosine, secant, and cosecant. The period for the parent function's pi. So all the babies are pi/b, not 2 pi. You're going to have to remember that. If you can't remember that, you're going to get marked. That's the way things work. All right? And then, but with tan, you have to split the period in half to get those first asymptotes. So Reese had a tough question. Hey, what's the period? And I threatened suspension when I asked what's pi/2 plus pi/2. Pi/4? Come on. She didn't say that. All right? It's pi. But with the period being pi, you got to split it in half to get these first asymptotes. Tangent has 0, 0 as a point. Of course, this is without shifting. We're not shifting right, left at all, and up, down yet. We're just going to get, the whole idea of how to get your marks here and get your graphs. And the coordinate plane works well. I didn't put the coordinate plane on my notes. I should have. The coordinate plane that I have for you guys. And then it's not an amplitude, but the A value is a stretch shrink factor. It's these 3/4 and 1/4 values here. That's what, the A is. Now, one thing to mention with tan, I forgot when I turned my back. You probably can't hear me at all. Sound's going to be horrible on this computer. This increases. Cotan should be done with that. Still a period of pi/b, but it decreases. And I lost my arrow here. Forever down. So why cotan's easier is whatever the period is, that's the next asymptote. The first asymptote's at 0. Why? Because what we just did, now you're going to have to memorize it. Just like, really the only things you have to memorize is sine, cosine, and then these two tan and cotans graphs. Because what do we have to do for secant, cosecant? Graph sine and cosine. And then just do one extra step. So it's really not a whole heck of a lot. Then again, the A value just gives you the stretch shrink factors. Decreases when you read it. Decreases. All right, here we go. Let's get our next student. He's so mean. 3. I swear, isn't it when Reese goes, then Aldona almost always gets picked? I feel like that happened in the very first day in here. Remember that? Who got picked first? Because whoever got picked first, the other one laughed at him. Didn't she turn around and laugh at you? I remember that. I'll never forget that. And then here we go again. We're in the same spot. Huh? What's the matter?
Never gonna forget.
I'd never forget. I never forget anything. All right? Who owes me quarters in here? Let me think. Who's rented calculators and they're defaulted on their loan? I don't know. Maybe not in this class. When I look around. Have you?
I've always been one.
You okay? Actually, I don't think you guys rent many calculators in here. Yeah. Okay. So what's that now?
I only give you for the charger.
Oh, the charger. Oh, do you owe me? I thought you were getting a quarter out of your pocket. I thought you were feeling guilty. All right. Eldona, what's the amplitude? Eldona, what's the amplitude? Someone tell her. None. You got tricked. But there is an A value of 2 now that stretches it. Hey, Eldona, what's the period? I couldn't hear something. What? Oh, what number's in there that you don't see? What number's in there? I'm actually holding it up right now. 1. And it's pi over b, so what's the period? Pi over 1. Okay, we got to get this whole how to find the period thing down for all of our graphs. Otherwise, the chapter test is going to be a disaster. Okay, so it's pi. Now, I literally just told you this, Aldona. What do you have to do with pi? Like, what are these values right here? What do we have to do with this period to graph tangent? We got, okay, I'll write it out, put it up here. We got to do what to that period to find these asymptotes here? Got to take, what's this fraction right here? Take half of the period. So what is half of this period? What am I going to put right here? Sorry, I can't stop moving. So what is half of pi? That's pi over 2, but the period's not pi over 2. This asymptote is pi over 2. And this asymptote is negative pi over 2. So this is what you have to get going on this. And then Aldona, what are those next coordinate or next x values? What is half of pi over 2? And you have to put pi over 4. You have to think about it. Yeah, I want to put this one here, hint, hint, and this one here, hint, hint. Because Aldona, one more thing then. What is negative pi over 4 graph to? Does it go to negative 2, 0, or 2? Which one is it from what you just saw from the parent? It's increasing, so it's down here. 0, 0. Once you get that right, I don't think I have to bother you here. Bless you. And then I'm a meanie. I'm going to make you do 2 periods today because there's no shifts. So 5. No, she gone. You're lucky, Sarah. I hope you're watching this movie because now Nathan has to go. Nathan, 1 pi over 4. What's this one? 3 pi over 4. I didn't want to give away too much. What's the next one? And then what's the next one?
5 pi over 4.
And then what's the next one?
Wait, I took 6.
Because I need 1, 2, 3, 4 of them. 3 pi over 2. And 3 pi over 2 is that 270 marker, which without any shifting right, left, or any change of the period. That's this. And then you see if you can answer this now. Just a 3 pi over 4 comma. And do it a second period. So what would 3 pi over 4 be? Comma what? -2, 0, or 2?
2.
Oh,
Two, sorry.
-2. Gotta go. And then pi comma.
0.
I love these questions. 5 pi over 4 comma.
2.
I love being able to ask these. It really awakes the brain when you have to ask that. Okay, let me put 2 more things on this one, and then because of time, maybe not the others. Hey, what's the range? What do you think, everybody? Look at one part of this graph, just one, and tell me what the range is. 3, 2, 1, go. All real numbers. Nice. Good. Very well done. One graph takes care of it. So we got no range thinking to do. Nothing to even do. And then asymptotes. Well, you just got to figure out with tangent and cotangent, it's x equals. If you don't, oh my gosh, the things if you walk out of here and you claim your math professor next year, oh, that teacher never taught us vertical lines. I'll come out of the right through the wall like the high C man. Oh yeah, you're wrong. I've been telling you that forever. What a x equals you how dare you say that? Whew. All right, so how far apart are these asymptotes? How far? They're the period. They're the period away. Pi n. All right, there you go. All right, so that's actually easy to do too. All right, while we're here, I'm going to go to this one, but I'm going to make this cotan. I don't know why I'm like anti-cotan on this on the actual example sheet. Okay, so let's make that third one a cotan. Let's just go ahead. Let's go down here. Okay, so -0.5. All right, that's our A value. You know, and I don't care if you really make it to scale. Just mark these. And sorry that we just have bland coordinate planes on the test. Oh my gosh. You guys, I almost threw up on some of your graphs. He's so positive. Here's why is this the way? All right, here's my first mark, and then here's my second mark, here's my third mark, and then here's my fourth mark. So then here's the sine graph. Sine, and then I go up to here, and then I'm to here, and then here, and then here, and then here's my sine graph. And that's what I'm getting for sine. Why? Could you at least try to get the spacings a little bit better? Oh, you kids. The things that I have to deal with. Oh, okay, I'm done. You know what I'm talking about, right? Very annoying to look at when you do that, Grant. Now I'm talking about your test. I literally just looked at your quiz. All right? I mean, you purposely went out of your way to make the distances like this one's 1 millimeter. This one will be 7 millimeters. I think you got to ruler out and measure the unequal distances. Oh, anyway, where are we at? You know what, Grant? You're answering the question now, just because. What's the period?
The period is pi over 2.
Oh, okay. What's the amplitude?
Yeah, 2 is nothing.
I was trying to get you. I was ready with my wrong. All right, now Grant, this one you do have to do the cosine sine stuff. What's half of pi over 2?
Pi over 4.
Pi over 4. You know what? We're going to go way low here. Then we'll definitely be out of the way. And then what's half of pi over 4?
Pi over 8.
Okay, probably maybe a little out of order on this question, but we got a couple things going on. And then, what's the third one? I'm doing my little thing. 3 pi over 8. I don't know if this is a good spot for it or not. Yeah, it's probably fine as long as I'm above that 0.5 if that ends up being one of the things. Okay, now, Grant, I'll just give this to you. For cotan, you're supposed to know that the first thing is an asymptote. That's why I went and did this. And by the way, I'm not doing 2 periods, but if you did, you just cut and paste and put the negatives there, right? Isn't it easy to do 2 periods? All right, so that's why I'm not doing it. Laziness. Pi over 8 comma. Careful. Cotan is supposed to look like this, decrease. You know, it's supposed to go like that. And I got -0.5 in front. So what's pi over 8 comma? Is it 0.50 or -0.5? Aye. It flipped. So now when it says flipped, right?
Oh, yeah.
All right, that's what you missed. And then what's pi over 4 comma?
0.
And then 3 pi over 8 comma. And then I aim to keep below that. And then this is where the next asymptote is. Again, for 2, you just go ahead and cut and paste the negatives and throw it on the other side. You know what? I want to move on. So I also wanted to cover number 18 from the homework. What happened?
Oh, no.
What's wrong? I'm scared.
I forgot the
It was flipped. Yeah, we got to flip over the x-axis. Okay, next one. Yeah, we'll do this one just because we got some fractions. Who did I skip on? It was you. Did you answer a question?
Yeah,
Did he?
Yeah.
All right. Okay. 8. Nice. Matt, good. Did you go yet, Matt?
Yeah.
Good. You're going again. What's the period, Matt? What's the amplitude? Nice. So I get a 2. What a jerk teacher keeps asking, trying to get people to make them wrong. All right, and then what's this asymptote there and there, both positive and negative? Oh, no, it's not. Oh no, you're going the wrong way. You made it. You gotta cut this period in half in order to get this. That's pi over 6. Okay, because again, these are where the asymptotes are for tangent graphs, and the distance between these asymptotes you should be able to figure out fractionally is pi over 3. That is a distance of pi over 3. So from that asymptote to the next one. One more thing, what is the halfway between there? Like what's this x value? Did you hear him? Pi over 12, just multiplying the denominator. That's why, well, you guys better be thinking to yourselves, I am silly for making fractions so hard. Half of a fraction, you just multiply the denominator by 2. I mean, that's you understand my frustrations. All right, and then one more time, Matt. It's just 2 tan positive. So what's negative pi over 12? Is it 2, 0, or negative 2?
0.
Oh, not one of the options. It's either 2 or negative 2. Because 0, 0 is the point here. So negative pi over 12 is what? Negative 2 because it increases. So yeah, we do have a capacity to have these numbers getting away from our dots. So you might want to erase and rewrite the numbers on a test so I can see your numbers as well. Grant, okay, because that was a problem as well, like not being able to really see the numbers that you have there. 4, 8, 11, 12. Is that you? Nice. All right, so Natalie, let's keep going. Let's do another period, and I'm going to go off this thing a little bit, and that's fine. I want to keep it equally spaced. So 1 pi over 12. What's the next one? Ooh, we're going to have to do some reducing. Tell me what it is as a fraction. Ooh, 3 pi over 12. 3 pi over 12. Oh, no, 3 pi over 12 is pi over what? But then remember what you just said there, because 1 pi over 12, 2 pi over 12, 3 pi over 12, 4 pi over 12 is pi over 3. 5 pi over 12. What's 6 pi over 12? Pi over 2 is where your next asymptote is. And then I won't even bother you with this. It's negative 2, 0, 2, just to accomplish 2 periods. So a tangent is a little bit more work for the 2 periods. Cotan not, you just cut and paste on the other side. So I was kind of lazy on that one. Ooh, this is a nice one. Yeah. Oh, did that go? 13. Nice. 13. Okay. So what's your amplitude? Nice. All right, it flips those. Hey, let's just get it out of the way. 2.5, negative 2.5. That's when it comes down to graphing. What's your period? Pi over 2. What do you get? 2. Okay, but what do you do for tan? What is that value? And what is that value negative? No. 1 and negative 1. And this is going to be weird because it's going to look like it's going to be part of my asymptote. So I got to really separate that. Especially this one. I got to make these real little dots. See, that one now looks like it's part of the asymptote. So someone told me in 4th or 5th hour, make that one look like that. There you go. Okay, and okay, what's this number right here on the x-axis? What's that number right here on the x-axis? Yep, I'd take that. And then it's negative 2.5. So 1/2 comma, what would it be? 2.5 or negative 2.5? It's flipped. There we go. I'm on that 2.5, 0, and then this is negative. So this is upside down. Okay, and then come on, 1/2, two halves, 3 halves, 4 halves, 5 halves, 6 halves, and then you could do it again. That. Okay, I'm good. Don't ever do that. That was terrible. All right. In fact, I feel guilty about that. That's better without the dots, but do draw the dots. Okay, now, what do you see here? Let's talk to 3 more people. 2, Angel. What do you see here? Don't look at the shape. There's no shifting right now. We don't know what shifts are. Let's pretend. What do you see, a tan or cotan? Which one goes through the origin like that? Tan or cotan? Couldn't hear you. Tan. So it's y equals tan. Now, you guys did a real bad job with this section. The graphs look like this when I looked at the quiz that we already had. A real bad job of like marking up your graph. So for instance, I see pi over 4 here. So what is this here? What is that right there then? Pi over 8. That's where the asymptote is. So therefore, this is negative pi over 8. So this is how you had to mark it up if everything wasn't marked perfectly. This didn't go very well. I wasn't too happy with the section of reversing. Then the other thing we weren't looking at is the y-axis things. So if that's 2, what's this? Well, what's that right there? Everyone, that's 1. So what I'm saying is, it looks like that you have a very valid argument that this quarter value right here is at 1 and negative 1. So what's my A value? Yeah. Oh, my A value is 1. All right, because I have those marked there. But is it positive or negative for tangent? Look at this graph. Is this the way tangent's supposed to go, or is it flipped? It's flipped. Now, here's the last thing. What is the period when it goes from pi over 8 to negative pi over 8? Pi over 4. So the period is supposed to come from pi over b, and it's pi over 4. I'm not asking Angel, I'm going to ask everyone. What is b? 3, 2, 1, go. It's 4! Staring you in the face. All right, so therefore 4 goes right cha. And then you need either an x. We use theta a lot. I like x too, because x, y axis probably should be in terms of y and x with radians. So b is 4. That's how you do this. This next one's really silly. But it's like part of a test. Like, well, student number 1, Vanessa. Yeah, how could we not? You go almost every day on these calculators. Who do I feel like? Nathan, do you ever get picked? No, Angelina, you do. Grant, I just pick you on purpose. All right. Matt, you don't get to go a lot? No comment. Rachel, how about you? You're shaking your head. Does it skip you all the time? Kaylee, I know you get hit a lot here. He's never here. I should just call on him every day, no matter what, too.
Yeah.
I like
Yes?
I didn't get picked until like October.
Are you serious? That's hilarious. Look at Aldona over there. I get picked every day. All right. I forgot where we're at here. Vanessa? Hey, what is this, tan or cotan? I seem to be obsessed with. Oh. Now, I think I know why you said that, because it increases, right? No, that's incorrect. Actually, tan increases. So guess what that is, actually? Say the other one I said. Tan. Also because it goes through the origin. Then we got to do the same thing again. This is 4. That means this is 2. But then look at where this point is at this quarter value. It looks like it's at what number? What number for y? 1. So my my A value is going to be 1 again. Y equals 1, and then we figured out this is actually more like a tan. Is it upside down or right side up? Right side up, so it's positive. Is that what you said? Okay, and then what's the period? Sorry. If that's pi over 2, which means this should be negative pi over 2. What's the period? So pi over 2 to negative pi over 2. What's the period? So what's this distance from here to all the way over here? It's the question I asked Reese. What's pi over 2 plus pi over 2, which is pi? So pi over b equals pi. What number is actually down there? I couldn't hear you. 1. You know what this is? This is just the parent function. There was nothing special about this one at all. It was just the parent, right? That's all it was. And then who gets picked last? Thinking that they're done for the day. Who do we need? 17? Oh. No, I'm going again. 14, that seems new. 8, 9, 10, 11, 12, 13. You get picked a lot, don't you?
Yeah.
You have to go. Let's keep going. Let's see if the calculator's impervious for getting 17. This is hilarious. I'm gonna hit this until we hit 17. Oh my gosh. Did you break into my computer? I think you broke into my computer. Yeah! 17.
Oh my God.
All right. Were you picked in there a couple
I was picked
times?
first.
And don't say the G word. You're suspended. This is a public school. Did you hear him? Thank you.
Oh,
Uh-huh.
yeah.
Yeah, you can't do that. You just offended the atheists. All right. Okay. All right. 17, 14. All right, Lindsay. Oh my gosh, I'm obsessed with which graph, cotan or tan. It's tan. Is it right side up or upside down? Nada. And then this is 1. Wait a minute. Oh, this is the quarter value, and we're up here. Interesting. So what's the A value? I should have said, what's the amplitude? They go, wrong. All right. 2, and then it's right side up. And then what's the period if this is pi? What is the period? So pi this way and pi that way is what? How far? 2 pi's. And then what do you think b would have to be, knowing your fractions now from your training from Mr. Samuelis? What would pi over what number equals 2 pi? 1/2 is b. And there you go. That's how it fits, and that's how it works. Okay, sorry to bore you. We had a lot more time in the other periods. Here is, I was going to do this one. Are you serious? We're almost done. What did we do at the beginning? Did we do anything?
No.
Where did we lose our time?
You were making jokes.
Oh, did I tell stories again? I'm sorry. You're saying it's my fault. All right. Okay, I was going to cover this, but gosh golly, there I go swearing again. Let's just do it tomorrow. Remind me to do this tomorrow, and I'm just going to end the video. Oh, son of a nutcracker. I have to go do stuff. I have to go somewhere and make myself a better teacher, as if ever that's going to happen. Right? I don't even listen. You'll find you should watch. I should tape tomorrow's thing. A million teachers at this what do you call it, seminar or whatever. Teachers are the worst students of everyone. We're all just a bunch of jerks in the stadium, and